All right, so first I guess we need to define what a digit is. There's 5 digits right there. Okay? Originally the word digit came from your toes and your fingers. All right? But guess how we use them now? Well, guess what we use with 10 things? We learn to count, okay? So all of our counting systems in this world, on this earth, is based on 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it sort of starts over with 11, 12, 13, and so forth, right? So the digits are the numbers or the individual characters in a number. Let's put it that way. So here's a digit, and there's a digit, and there's a digit. So this number has 3 digits in that respect. Does that make sense? So the term digit then has sort of evolved with our language. Originally it was these were digits, and now it's these are digits. Got that? So what we mean by significant digits is that whenever you're doing measurements, sometimes you get different numbers of these digits, and that affects how the answers are written. And sometimes you can have a really big number of digits, and they don't really mean anything at all. So what we want to do is figure out how to handle those, okay? So there's different categories of handling significant digits. There are how to handle significant zeros. Okay? There are significant digit rules in addition. Okay? And subtraction. The rules for addition are the same as those for subtraction. Okay? There's a different set of significant digit rules for multiplication. And I bet you can guess what the other thing that these rules apply to are. What's it for? Multiplication and division. Very good. Okay. And then there's also a set of rules, a separate set of significant digit rules for exponents. And make sure I spell this right now. Logarithms, I believe it is. Did I spell it right? Do y'all know? Logar. Well, I transposed those. That's not good. Huh? See, I can't talk and write at the same time. What's that thing about chewing gum and walking at the same time? That's kind of me. Okay? Did I spell it right? Yeah? Okay. Now, we're going to kind of make it a little bit easier because we're not going to really learn this rule at all. Okay? It's a little bit much, and we only use it in one unit, whereas these other rules we use all the time. So we're going to learn about significant zeros. We're going to learn about addition and subtraction significant digit rules. And we're going to learn about multiplication division significant digit rules. And then we're going to kind of gloss over this and use the multiplication division rule for these. Okay, do y'all know what logarithms are? Okay, yes? Who doesn't know what logarithms are? Everybody does? Have had it? Good. Wow, fantastic. Because I've had a lot of classes where students, nobody knew what a logarithm was. And this is great, man. So, do you know how to undo a logarithm on a base of 10? No, I don't remember that? Yeah, use it. Yeah, put the logarithm on a 10 as an exponent. So a logarithm is an exponent, and you undo it by putting it on a 10. Okay? All right. So let's start with significant zeros. Okay? Significant zeros. All right, let's first try to explain, and you know what? I know this is going to be difficult in the beginning because we're not going to get a lot of practice with it in the beginning. I'm going to give you this rule, and it's kind of like not going to make a lot of sense, maybe. Okay? Now, some of you may have had it in physical science, and you got a leg up on the other people who don't, and that's great. Help them out, okay? If you know somebody, if you understand this stuff, and the person next to you doesn't, help them out, okay? It's okay. So significant zeros. The reason we have rules about significant zeros is because people are not always as good about writing numbers so they show clearly what the significant zeros are and what they aren't, okay? So we need to be very clear about when you have a significant zero. If somebody's written down a measurement, the digits should indicate to you how many significant digits there are in that measurement, all right? So let's say, for instance, if I have a measurement like this. I have 12.5 grams of table salt, NaCl. Okay? You remember this, Patrick? Significant digits? Yeah. Okay. So now just a word of warning, because this is kind of like looking at the future. Whenever you have a measurement, if you don't write the unit of measurement, okay, it basically doesn't mean anything. And let me give you an example. Okay, you want an example? I'll give you an example of why units of measurement are important. You ready? If you want 100, raise your hand. Slaps upside the head. What? You want 100 slaps upside the head? See, I didn't tell you what the number applied to. You got that? That's it. So you got to have something. You got to tell me what the number applies to, or like you're agreeing to what you don't know what you're agreeing to, right? Okay. So make sure you always put your units of measurement, and where it applies, always tell me what that unit of measurement and that number apply to, or that measurement applies to. Okay. Now there are occasionally things for which there are no true units of measurement. For example, percentages, if they're done properly, actually have no units of measurement. We'll find out how that works because they actually cancel out. But don't worry about that right now. Most of the time, almost all the time, except for percentages, at least in this class, except for percentages, anytime you have a measurement, you must have a unit of measurement. Got that? All right. So this number has 3 significant digits. Now, how do I know that? Because if I'm writing down a measurement, or I'm writing down a calculated number, all the non-zero digits I show are going to be significant. So the point here is, and you can write this down, all non-zero digits are significant. All non-zero digits are significant. Okay? That's kind of where we start with. That's when we explain about significant zeros, because they're the ones that kind of trip you up. All right? So what I'm going to do is give you the formal rules, okay? And then I'm going to give you kind of the easy way to remember this stuff, okay? Got it? So the formal rules about significant zeros are, zeros are significant if, number 1, they are between two significant digits. Oops, I still have a problem writing today. I'm just going to cross that out. Digits. 2 significant digits. Okay. Well, we already said that non-zero digits are significant, right? So you got to head up. You kind of know where we're headed here. Okay. So if I've got something like, well, we'll get back to that. We'll go to examples in a minute. Let's go to rule number 2, and then we'll come back to the number 1 with examples. Okay. Rule number 2 is in 2 parts. Rule number 2 is in 2 parts, and for a zero to be significant, it's got to meet the conditions of both parts. You got that? So rule number 2 is in 2 parts, and if a zero is going to be significant according to rule number 2, it's got to meet both parts of the rule. All right. So a zero is going to be significant if it follows a non-zero digit and a decimal place. All right. So under this rule, if a zero is going to be significant, it must both follow a non-zero digit and follow a decimal place. Now, follow just means the direction we read, to left to right. Okay. Got that? We're not learning Hebrew in here. We don't read from right to left. We read English. Yes? You guys just don't laugh at anything in this class, do you? Man, I don't get any kind of, no love at all. God. Okay. You're all racist, junky old stuff. All right, let's look at number 1 here about how this applies. Let's say we have 120.5. Yeah, 120.5 grams of NaCl. All right. Now, according to the rule, this zero is significant because it's between 2 different non-zero digits. That make sense? So this is a significant zero. How about we do this? What do you think? How many significant digits in this number? Digits total, not just zeros. Digits total. 8 significant digits, because there are 5 significant zeros. Somebody said 5 a while ago, and I knew right away you were counting zeros, right? Okay, so there are a total of 8 significant digits, because all these zeros are significant because they're between 2 non-zero digits. Okay, so that's rule number 1. Got that? Yes? Okay. So according to rule number 1, then, all these digits are significant zeros. Did they follow it? Okay. Good question. Let's do that. How many significant digits here? Only 2. Because they're not between 2 significant digits. Was that your question? Okay. So if they're not significant, they're called insignificant. Six insignificant zeros, correct. That's a pretty big number. Let's do a really small number. According to our rule, how many significant digits in this number? 2. Because none of those zeros are going to be between 2 significant digits, right? Well, this is sort of a transition area. I'm going to also explain why also those zeros are not significant under rule number 2. Okay, under rule number 2, zeros are significant if they follow a non-zero digit and a decimal place. Now, these zeros follow a decimal place, but to meet that rule, we have to follow both of them, right? And they don't follow both. So unless it follows both, those zeros are not significant. Got that? All right, let's go to rule number 2 now and look at how that applies. What now? No. Oh, 6 significant? Yeah. 6 insignificant zeros. Well, if we really just say there's 2 significant digits here. Okay? All right, now let's look at how rule number 2 applies then. So I'm recording this video. All right, so you guys got to leave a little bit early, right? You got to leave, don't you? So your job then tonight, among other things, to make sure you watch this video and you get caught up on this last 5 minutes. Got it? Okay, good. All right. Let's see. So the next rule is zeros are significant if it follows a non-zero digit and a decimal place. So let's do one of these. Let's say I have 0.012000 grams of NaCl. Okay? What do you think? How many significant digits in this number? 5 digits that are significant. Okay? That's because these 3 zeros are significant because they follow both a decimal place and a non-zero digit. The 1s and 2s and 3s and 4s, 5, 6, 7, 8, 9, and zeros. Not zeros. 1, 2, 3, 4, 5, 7, 8, 9. Those are always significant, assuming, and we have to assume, that the measurement or calculated number has been written properly to start with. Okay? So these are significant zeros here that I've bracketed. I guess that's the word for it. So we have a total then of 3 significant zeros, 2 other significant digits because they're non-zero digits, and then 2 insignificant digits over here, right? Okay, so that's 5 significant digits total in that number. Does that make sense? Okay. All right, let's do this. How many significant digits in this number? 6. All of them are significant. These zeros are between 2 significant digits, so they're significant. Got that?